Welcome back, everyone. I am so excited for this next section. And of course, we're starting off with our 6-step machine learning modeling workflow. We've got our problem definition, data, evaluation, features, modeling, and experiments. Again, we're trying to just make this almost second nature with whatever machine learning modeling tasks we come across. If we've got some data, these are some steps that we can take to figure out insights from that data. Now, let's have a look at what tools we can use. And what's important is that in this section, we're going to have a look at TensorFlow. And now you might be wondering, okay, I see PyTorch here, I see scikit-learn, we've already had a look at scikit-learn, but what is TensorFlow? Well, that's what we're going to be diving into in this entire section. And we're kind of going to be teaching this one a little bit differently to how we've looked at the pandas, matplotlib, numpy, and scikit-learn section. Now, the reason being is because the book on TensorFlow and the book on deep learning and neural networks of what we're going to cover in this section is not as established yet as what scikit-learn is. So scikit-learn's been around for over 10 years, whereas TensorFlow, the version we're about to use, only came out a couple of months ago. So if you're watching this in 2020 or later on, really, the version of TensorFlow, TensorFlow 2.0, it might be a higher version by now, only came out at the end of 2019. So what we're doing in this section is we're using cutting edge stuff. And what's even more exciting is that we've got a new contender to our workspace environment, and that's Google Colab. Now, the reason being is because we're going to need access to a GPU. We'll have a look at that in a second, but this is our workspace that we're going to be using for this section. Now, if you're not familiar with Google Colab, that's okay. We're going to go through it. It's very similar to a Jupyter notebook. Now, you might be thinking, what is TensorFlow? And that's a great question. Well, TensorFlow is a deep learning or numerical computing library. That's probably a better term for it. Now, it was first conceived by Google, and they used it within their own, like it was an internal software library for all of their deep learning and machine learning needs. And it's actually now open source. So anyone can contribute to TensorFlow. The most recent update, the TensorFlow 2.0, it is packed full of updates that the community, the people like yourself and me, who use TensorFlow have asked for, like, hey, this didn't really work. Can we make it a bit better? So older versions of TensorFlow, you don't have to worry about. What we're covering is the latest stuff here. TensorFlow is used to build deep learning and neural network models to gain insights out of unstructured data. Now, in the previous projects, we've dealt with data that's available in a data frame, so something that looks like an Excel spreadsheet. It has rows and columns. But deep learning is more suited to unstructured data, such as photos or audio waves or natural language text, unstructured data that doesn't really have any specific structure. And now TensorFlow allows us to build a deep learning model, kind of like a neural network, well, exactly like a neural network, to gain insights out of this unstructured data. And it also allows us to check and evaluate how our neural network, which is another form of machine learning model, is doing. Is it getting things right, or is it getting things wrong? Now, why TensorFlow? Well, the most important thing is that we can write fast, deep learning code in Python. Now, what I mean by fast is that it's code able to run on a GPU. And if you're not sure what a GPU is, don't worry, we'll check that in a second. And TensorFlow is able to access many pre-built deep learning models. Now this is important. So like scikit-learn has a bunch of machine learning models built into it. We've already seen scikit-learn. TensorFlow also has the ability to access pre-built deep learning models. So we'll see how to do that in the upcoming project. It also enables you to do the whole stack. What do I mean by that? You can pre-process your data using TensorFlow. You can model it using TensorFlow. And you can also deploy a model that you build using TensorFlow. And we just spoke about this one. It was originally designed and used in-house by Google. Now it's open source. So people like you and me, we have access to exactly the same software that Google use in-house for their deep learning and machine learning workflows. Well, we spoke about a GPU. What actually is a GPU? Well, a GPU stands for Graphical Processing Unit. And the main thing you have to know for now is that it's a lot faster than a regular CPU is at doing numerical computing. So if you remember, if machine learning is finding patterns in data, aka turning data or information into numbers, finding patterns in those numbers, A GPU is what's going to help us to increase the speed of finding those patterns in those numbers. That's all we need to know. Now, if you remember way back in the Machine Learning 101 section, so this is why I've got throwback here, we looked at this slide, choosing a model. So we've got structured data here. You might choose a model and you might use one of these libraries on structured data like CatBoost, XGBoost, or Random Forest. We saw that in sklearn. Now, we're going to start working with problem 2, unstructured data. So we've got photos or audio files here, and we've got model 2, which is more like a neural network. This is kind of what you'll see if you Google up neural network. And now, these type of models, deep learning and transfer learning, work much better on unstructured data like we've just talked about. And so TensorFlow is what we can use to build deep learning models. And TensorFlow Hub is where we'll be going to use transfer learning, aka taking what one model knows and using it in another model. Now you might be asking, what is deep learning and what are neural networks? Well, I want you to think of it like this. Deep learning is just another form of machine learning. And neural networks, something like this, these are the type of machine learning algorithm that are usually referred to when we talk about deep learning. And so, if we have this image of a dog and we're trying to identify, that's my dog, 7. How beautiful is she? And that's Bella in the background. But let's say we're trying to identify the breed of 7. A neural network might look at this image, convert it into numbers, and then go, okay, this little model here is going to remember what a leg looks like. And then this one here is going to remember what eyes look like. And then these ones, who knows what they're going to figure out. And then eventually we realize that this is an image of a Labrador, if our neural network is learning right. So this is what I want you to imagine a neural network as, is that the same process with all of our other machine learning models that we've looked at, is you have an input, some kind of data, and then you have a machine learning model here, in our case a neural network, and then you have some sort of output. Now, a neural network, you might be wondering, what are all these little nodes here? They're also called nodes. Well, these are small models within themselves. So what's going to happen here is that each of these small models is going to add up and figure out some kind of pattern in this data and then learn what that pattern relates to, aka the label. And so where does deep learning come from? If a neural network is just another type of machine learning model? Well, this is where the deep part comes from. When building a neural network, you might use multiple layers. So see here, we've got our original one, but then you might add more neural networks on top of your original neural network. And what this might do, and I say might because again, it's a lot of trial and error in this sort of model finding. That's why I said in the beginning, the book on deep learning is yet to be fully completed yet, because we're still working out the best way to lay out these neural networks. And so I've got here a few more boxes than what we had in the previous slide. And what this means is that as you add more layers here, these other nodes, these smaller models in the neural network, are going to start to be able to detect more and more features, and thus hopefully getting better at identifying the information in our unstructured data. Now, what kind of deep learning problems are there? Well, we've spoken about classification. We've also seen that in a heart disease project. But you might want to classify what kind of dog breeds are in an image, or whether an email is spam or not. In this case, this email is definitely not spam. Otherwise, there's a sequence-to-sequence problem, also known as sec-to-sec. And now, this is a kind of problem that happens with Siri or Google Home or something like that. It also happens with Google Translate. So it takes an audio wave, and it's going to translate that into some sort of text or command. And then finally, there's object detection, which is similar to image classification, but now you're trying to find out where a specific object is inside an image. So this is a kind of deep learning problem that a self-driving car might have to come into, or will come into if they're using cameras, right? It's trying to identify what objects are in an image. If a Tesla self-driving car has 8 cameras, it's always trying to pick up what objects are in its way. And I mean, there's many more deep learning problems out there, but this is 3 of the main ones that you're going to come across in your day-to-day life. Okay, and we mentioned transfer learning before. So what is transfer learning and why should we use it? Well, the main premise of transfer learning is taking what you know in one domain and applying it to another. So if you're training a machine learning model to pick up different dog breeds and images, and you're trying to train a machine learning model from scratch, that can be both expensive and time consuming. But if you've already got a machine learning model which has learned to identify other objects and images, the beautiful thing is you can use transfer learning, so taking what that machine learning model or neural network, taking those patterns that it's learned in another set of images, and then apply those patterns to your own problem. So this leads us to the question, why not take advantage of what's already out there? Why not take advantage of what another model already knows? That's what we'll be looking at doing in this project. And more specifically, what are we going to cover? Well, if you remember our scikit-learn workflow, our TensorFlow workflow is very similar. We've got to get data ready, but this time it's unstructured data rather than structured data. And this is the main premise here, and I will stress this until I go hoarse, is getting the data ready is essentially just turning our data into tensors, hence TensorFlow. And then once our data's in tensors, we pick a model to suit our problem. We're going to use TensorFlow Hub for this. And then we'll fit the model to the data, so aka get the model to find patterns in the data for us. And we'll learn how to make a prediction once our model has learned some patterns in our data. Then we'll evaluate our model to see if, hey, are these predictions, are they any good or not? We'll see how to improve through experimentation. And then we'll save and reload our trained model. Now, in a dot point form, we're going to go through an end-to-end multi-class classification workflow with TensorFlow. We'll see what that is in a second. We'll learn how to pre-process image data, so getting it into tensors. We'll learn how to choose a deep learning model. We'll learn how to fit it to the data, so learning the patterns. Then we'll learn how to make predictions with our deep learning model, so using the patterns that it's learned. Then we'll evaluate our model's predictions. We'll save and load our deep learning model. And then we'll use a trained model to make predictions on our own custom data. Oh, far out. This is a big section, but I'm excited. Now, what is the problem we're going to work on? It's a classification problem, and it's the Kaggle dog breed identification problem. So determine the breed of a dog in an image. And now this kind of problem is multi-class classification. So that means there is more than two options, but we'll have a look at this shortly. Now, where can you get help with all of this? Because we're learning concepts and code at the same time, all within a project, do your best to follow along with your code. If in doubt, run the code. Remember, try it for yourself. Because we're using Google Colab, we'll see this in a second, reading a doc string is a little bit different to a Jupyter notebook. You have to press Shift, Command, and Space to read it. If you're still stuck, don't be afraid to search for it. You'll come across Stack Overflow or the TensorFlow documentation. And then try again using what you found on Stack Overflow or TensorFlow's documentation. And then finally, if you're still stuck, never be afraid to ask. And of course, don't forget the Discord chat, which hopefully you're signed up to. Hopefully you're in there interacting with the other students. And now, without any further ado, let's go find those doggos.